Hi people, welcome back to the third lesson on assembly supported beams. You have a beam, not too complicated. Assembly supported, the beam just got a bit of thickness, okay, just shown differently, but it's still a line, but just a thick line. There's a UDL of 12 kilonewtons per meter, and it goes over the UDL up to there, and it's got a point load acting at an angle of 30 degrees of that amount 2 meters away from the end, okay. And have you seen that there? It says the beam weight is 8 kilonewtons. What does it mean? What does the beam weight means? Okay, that means the beam weighs 8 kilonewtons. That means there's a point load of 8 kilonewtons acting vertically downwards at the center of the length of the beam. So before you start, you need to show it there. Okay, alright, let me see. Alright, I'm okay there with that. So let's see the length of the beam. That's 2, 3, 6. So the beam is 8 meters long. So that means the point load is sitting exactly 4 meters from either side, dead in the center. So if that's 4 there, so I'm going to say it's sitting over there somewhere, like so. Okay, so that's my load of 8 kilonewtons sitting 4 meters from the end, 4 meters there. So let's see. I'm going to project this line down like so. So if that's 2 and that's 1, that's going to be 8 kilonewtons there. And that's going to be, there we go, 1 meter. Okay, so 2, 3, 4, and from there to there is going to be, that'll be 2 meters. Is that okay? From there to this 3 meters, take the 1 away, so it's 2. So that's 2 plus 2 is 4. So that's 1 plus 1 plus 4. So this load, or remember, I said it the other day in the previous lesson, that the weight of an object always acts vertically downward through its center of gravity. So the beam weight is accounted for, right? Which just is a point load sitting dead at its center vertically downward. Right? Let's take moments. Alright, we're gonna have VA and VB, and notice there we've got a point load. So what we're gonna do, we're gonna have to resolve it into its components. Okay, so that's going to look like this. And it's going to look like that. Okay, right. That angle inside there is, it's 30. Okay, so that's going to be 9 cos 30. 9 cos 30. Maybe I should just change this color here. Do this rather to it. 9 cos 30. And that's going to be 9 sin 30. Alright, so that's 9 cos 30, 9 sin 30. Now remember, these forces are acting at this point over here. So that force is acting over there, and that force is acting over there. Okay? Right, I'm taking moments. I'm going to take moments about the pin joint first. Oh, my apologies. Let me first put in my forces. Let me first put my forces in where I think it's going to go. Right, so I'm going to have, that's a roller joint, so I'm going to have VA. I'm going to have VB. I'm going to say it's going upwards like so. And I'm going to have an HP. Why am I going to have an HP? Because there's a horizontal force acting, and because that force is acting to the left, I'm going to assume that HP is going to the right. Okay. And what did we do in frames, in trusses? We took moments about the pin joint first to eliminate those two reactions. and find that one there. So that's what I'm going to do now. So I'm going to say the sum of the moments about B is equal to 0. Right, here's my hinge. I'm free to rotate around there. Right, I'm starting with VA, and VA is positive with respect to B, so it's VA, and how far is VA from B? It is 1 plus 3 is 4 times 6. Are there any other forces wanting to tend to turn the beam clockwise about B? I don't think so. Okay, right, and it's going to be minus, I'm taking this one here, and what's that one? Is 9 sine 30, so it's minus 9 sine 30 times, and how far is it away? It is 2 meters away. Right, minus the weight. How far is the weight from B? It is force, and it is minus 8 times 4 meters. Alright, I'm doing the UDL. Minus. Why is it minus? It's also acting clockwise with respect to B. And it's a UDL, so it's minus 12 times. And how long is it? It is 3 meters long. 3 meters long. Okay? Remember there, that's just the force. We still need to multiply it by its distance. And how far is the distance? The distance goes from the center of the length of the load to the point of rotation. So how far is it from the center to there? It is 3 over 2, which is 1.5. Okay? Plus 1, plus 2, plus 2. So it is 2, 4, 5. 5 plus 1.5, I believe it is 6.5. 6.5. Right. This force here, the 9 cos 30, it's acting over there. Will that have any moment effect about B? No, it won't. Why not? Because it goes to the point of rotation. Okay. So, as far as forces go, and of course HP also goes to the point of rotation that is. So, we got 1, 2, 3, 4. I'm checking 1, 2, 3, 4. There's no more. So, it's equal to 0. So, therefore, VA is equal to, let me just pause it for a second. Work at the answer while I'm pausing. Right, people, I got VA equal to 45.83. I hope it's correct. You need to check me. You need to check me all the time. 45.83 I get. It is 45.83 kilonewtons. Which I'll be working in. And if you leave it there, I'll take off a mark. Please put it in. And because the answer is positive, it means that our assumption that VA is upward is in fact correct. VA is, maybe I should put it over there rather. Okay. Right. Now I can either take moments about A to find B, or what else can I do? I can sum verticals to find VB. That's what I'm going to do. I'm going to say the sum of the forces in the vertical is equal to 0. Now people, I should take moments about A to find B, but I can also sum verticals to find B. That's the quick, dangerous method. Why? Because if I've made a mistake here, then I will make a mistake with VB. Okay, so if you want to do it this way, you need to be sure. You need to be sure that this is correct. Because if you got this wrong, and you sum verticals here, VB is going to be wrong. Okay, I'm going to take that chance. I'm going to sum verticals. Right, so I got VA, which is 45.83. Minus 8, which is the weight. Minus the 9 sine 30. Okay, so it's VA minus 8 minus that minus the UDL. Remember, it is 12 times its length, which is 3 meters long, and then it is plus VB. Let me just see, so it's 1, 2, 3, 4, 5. Have I got everything? Yes, I have. Is equal to 0. I'm going to do it over here. Therefore, VB is equal to, let me just pause it for a second. Right, people, and I get 2.67. Hopefully it's correct. 2.67 kilonewtons. And because my answer is positive, means that our assumption that VB is upwards is in fact correct. I'm going to do a quick check on my calculator. Okay, I'm going to just talk you through it. What can I do? Talk you through it. Right. I've got 45.83 plus 2.67. I'm summing verticals. I'm going to say minus 12 times 3 is 36. Minus 36 minus the 8. Okay, which is the weight of it. And then minus 9 times 30. What's sin 30? Half. What's half of 9? 4.5. So it's minus 4.5 minus 4.5 is equal to 0.00. So it's checking out. So the sum of the loads on the beam is equal to the sum of the reactions. Okay. Right, are we done? No, we need to find HP. And I'm going to solve, and I'm going to sum horizontals. So I'm going to say the sum of the horizontals is equal to 0. And how many horizontals do we have acting? We've got HP and we've got the 9 cos 30. So it's HP, and why is HP positive? Because I assumed that to the right, minus 9 cos 30. There's no more, it's equal to 0. Therefore, HP is equal to, so it's 9 times cos 30, which is 7.79 kilonewtons. Let me check that again. 9 times cos 30. Yep. And because my answer is positive, it means HP in fact does go to the right. So that's 7.79 kilonewtons. Okay. And people, that's it. Now you'll see, those of you who's looking at that orange, I think, engineering mechanics book, what the author does there, let me change the color here, what the author does there, which we are not going to do, what the author does there, he gives you, let's say him, yes, Howard Fawkes, I think it's his name. He will give you that reaction, and then what he will do, he will work at, like we did in class earlier, he will work at that resultant there and call that reaction at B, and then give you an angle there. You know, when we did the little triangle thing like we did, we are not going to do that. We're not going to do that. We're not going to do that. We're going to take this as VA, VB, and HP. Okay. We're not going to do that. We're going to use the reactions as I got here for the reactions for this problem. Okay. VA 45.83, VB 2.67 upwards, HP 7.79 kilonewtons to the right. So put in all the units of measurement, put in all the directions, and that's the answer, and I shall see you in the next video.